if you didn't watch part 1, please make sure that you go there and watch it. So now we are about to explain the laws and show you how to use Newton's second law in terms of calculations. So we have Newton's laws here. We have 3 of them. We have Newton's first law. You must know how to define it. So it says a body will remain at rest or uniform velocity unless a non-zero force acts on it. So what does that mean? Let's just break it down. So since the definition says that a body will remain at rest or uniform velocity unless a non-zero force acts on it. For an example, an object will never move unless there is a force that is applied on it, meaning that an object that is at rest, it will only move if there's a force that is applied on it to make it to move or to change, or for its state of rest to be changed. Yes. So you must know the importance of seat belts. This is under Newton's first law. So the importance of seat belts is that they prevent a person from crashing through the windscreen and from being thrown out of a vehicle. So you must know these guys. Then there's something known as inertia, which is the property of a body enabling the body to resist change. For an example, I know that you always actually use cabs or transportation, cars. Whenever a car is actually turning to the left, you find yourself as if you are actually going to the right direction. You are opposing the direction that the car is taking. For an example, when the car want to turn to the right, you find yourself or your body resisting what the car is doing, so you find yourself turning to the opposite direction that the car is actually turning to. And sometimes, let's say a car is at rest, then the person or the driver wants to start the car, then immediately when it's about to leave or when it's about to move, when it goes forward, you find your body actually leaning backward. What is that? So the purpose of, or the name of whatever that's happening to your body or what you're experiencing is known as inertia. That's very important. When the car wants to move, when it moves forward, it feels like you are going backwards. When it moves or when it reverses, you find yourself as if you are going forward. So whatever that's enabling your body to do that is what is known as inertia. So that is why it is actually the property of a body enabling the body to resist change. And there's Newton's second law. You must know how to define this one, and you must know how to use the formula. So it says that when net force acts on an object, the object will accelerate in the direction of the net force at an acceleration directly proportional to the net force and inversely proportional to the mass of the object. So mathematically, it is F net equals ma, where F net, it is the sum of forces, like force 1 plus force 2 plus force 3. That's F net, the total of the summation of forces. Then m is the mass in kg, acceleration is meters per second squared. The forces that are having an effect on the F net part is the horizontal, or are the horizontal forces from the free body diagram. So horizontal forces are the forces that you substitute on the F net side. Or option number 2, forces that are having an effect on the F net part or on the F net side are the forces that are parallel to the direction of motion. That's what you must know. There are 2 cases. It's either horizontal forces or forces that are parallel to the direction of motion, because an inclined plane is not a horizontal surface. That is where we'll find forces that are parallel to the direction of motion, but horizontal surface, or if an object is placed on a horizontal surface, that is where we'll get what horizontal forces that we will actually use to substitute them on the Fnet side. But if it is an incline, we do not have a horizontal surface there. We only have an incline, or the object on an incline plane. Therefore, the motion, or the forces that are parallel to the direction of motion, are the forces that we're going to use and substitute them on the Fnet side. I hope that makes sense, or that's clear. Okay. So this is a very important information, learners. Make sure that you master this. I want you to master this thing. After this lesson, I want you to be able to get the total when it comes to Newton's laws, whether you're in grade 11 or grade 12. Okay, now let's say we have object A. You can see that, okay, this is FA. The direction of motion is to the right. Then let's call this object A. Then that means that the surface is horizontal. The surface is rough. So we draw a free body diagram. This is FG. And if you didn't watch the first part where we're drawing free body diagrams, please go there and watch it. So we are given FA, then the surface, they're saying that the surface is rough, meaning that we're going to have FF. We explained why the lengths or the magnitudes are not equal. So Fnet equals MA. So as you can see that here, the surface is horizontal, or the object is put on the horizontal surface. Therefore, we're going to use what? Horizontal forces and substitute them on the Fnet part. So FA is positive, FF is negative. So we're going to use these horizontal forces because they're having an effect on the Fnet. Therefore, it will be negative FF plus FA equals MA. Then you can continue to solve whatever that they want you to solve. This is very important, guys. Very, very important. So on the Fnet side, you put the forces that are horizontal. Okay, direction of motion is to the left, same block, but now we say that the surface is smooth. So smooth surface, it means that there's no frictional forces. I've explained that before. Then you draw a free body diagram. We have Fn, why? Because it is in contact to the surface. The object is in contact with the surface. We have Fg, then we do have Fa here. But because of the smooth surface, we can't have frictional force. Therefore, we only have one force that's horizontal, meaning it's Fa. Therefore, Fnet equals Ma. We consider direction into consideration. So negative Fa equals Ma. This is your Fnet. So this is important, guys. Make sure that you follow up. Make sure that you follow up. Let's try this one then. We can see Fa is pulled at an angle of theta. The surface is rough. Then we have direction of motion is to the right. Then what you do here, you draw a free body diagram indicated by a dot. Remember, that's a free body diagram. A force diagram is when it's a diagram that is indicated by a box. So you show that Fa that is pulled. So there's no need for you to write the theta. Your teacher will see what you have done. So the surface is rough. Therefore, we do have what? We do have the friction or frictional force. Therefore, what you must know here when it comes to this is that we'll have components here, as I'm highlighting with this color. This is FAX, and here we're going to have FAY. You always do this whenever your FA is pulled at an angle. Then you can see now that the forces that are horizontal is FF and FAX. Then the forces that are vertical is FN, FG, and FAY. That's important. F net equals MA. Therefore, we take negative FF plus FAX equals MA. Alright. So you can actually simplify this further. FAX equal to FA cos of theta. Then FAY equal to, these are components, FA sine theta. We find the components on an incline and when the FA is pulled at an angle. So FF plus FAX, which is FA cos theta, equals MA. Then here, that theta you have on the diagram is the one that you're going to substitute on the formula. So this is your F net equals MA. Very, very important, guys. Make sure that you understand this, that whenever FA is pulled at an angle, you will have components. Always make sure that you understand this. Please like the video. What you must look at now, you show your components whenever FA is pulled. Bear that in mind. Now you show your vertical component of FA. Then as you can see that the surface is smooth, meaning there's no frictional force. So you only have one force that's horizontal. We only have one force that's horizontal, which is FAX. Therefore, positive FAX equals MA. We can simplify it further. We know that here we're having cos. Okay, let me write it smoothly. We have cos theta equals MA. Do not forget these, good people. So the theta is one that will be given on the diagram there. Okay. The second thing, or what we can actually talk about right now, is that, but before that, make sure that you understand this, please. Okay, we have our object here, object A. Then they say that the surface is rough. It means that there is frictional force. The direction of motion is to the left. FA is pulled, meaning there are components. We have theta here. We have theta, so make sure that you try to do this one on your own. Do not forget the components. Very, very important. We have our surface here. We have object A, and there's a tension connected to object B. Then we have FA here that's connected to object B. Then the surface is rough, meaning that there is frictional force both in object A and object B because they are in the same surface or on the same surface. So the motion is to the right. Let's actually show the F net of object A, but we start by showing the free body diagram. We do have FG here, and we have Fn. If you didn't watch part 1 of Newton's laws in our channel, make sure that you go there and watch it. So we do have Ft, or tension force. So the surface is rough. What you must know is that we do have frictional force. Therefore, the forces that are horizontal here, it's FF and T. That's very important, FF and T, as you can see. Therefore, F net equals MA. Then on the F net side, it's negative FF plus FT, or the tension force. Therefore, you can calculate whatever they might ask you to calculate, provided that you are given the other values. So for object B, you start by drawing the free body diagram. So we have force of gravity or gravitational force, or even weights. We do have Fa, and we do have Fn, and the surface is also rough for object B. We'll show FF. Then after that we do have, that's FT, we do have FF, the frictional force. So we have three forces that are horizontal. So these forces, they affect what, or they have an effect on Fnet side. So that's very important. You didn't put Fa on object A. Why? Because that Fa is not pulled, is not applied on object A but object B. Therefore negative Ft, let me put also that FF, since they are on the same direction. With negative FF plus FA equal to MA. So here you can calculate whatever that they want you to calculate, but make sure that you understand this. That's very, very important. So let me show you how they mark the free body diagrams. It depends on the mark allocation. If it's 5 marks, they're going to actually mark it like this. Each force has a mark. That's very important. Each force has a mark, so you must actually bear that in mind. I hope you understood this part here. Suppose you are given a table like this, so let's actually show you how to show the Fnet of object A. You draw a free body diagram, use your ruler, you have FG, and here we have Fn. Then what again do we have? We have the tension force, or Ft. Then they say the surface is rough, meaning we have FF. Therefore we have two forces that are horizontal. Therefore Fnet equals MA minus FF plus Ft. I can see that you guys are getting the gist of this. You're understanding it. So this is very important. Very, very important. Okay, let's actually show the information of free body diagram of object B as well as the Fnet of object B. If you understand this, there's no questioning Newton's laws that's going to be a problem. Make sure that you follow. This one is very, very important. Many learners are getting it wrong. So make sure that you get it, and share the video so that your friends can actually understand Newton's laws. So we have T here, and the object here is not in contact with the surface. So we have FG, doesn't matter if it is not in contact with the surface, and this is not Fn, but this is Ft. Why? Because it is not in contact with the surface. So that's very, very important, good people. So we will never have a normal force on this case, or in this case, because object B is not in contact with the surface. So this is what you must do all the time when you do calculations. You act as if object B was actually horizontal. You only do this when it is calculation. So as you can see, we have T and FG pointing to the right. So you do this only whenever you do calculations, not free body diagrams. So this is what you're going to do right now. Fnet equals MA, therefore negative tension, or negative Ft plus plus Fg equals MA. Therefore negative Ft plus mg. You know that Fg equals mg equals ma. Then this is our Fnet for object B. You only do this whenever you do calculations. You don't actually make this object to be horizontal when you draw a free body diagram. When you draw a free body diagram, you do it as it is. As you can see, that object B is hanging. But when you do calculations, you make it as if it was horizontal, because on the Fnet side We substitute the forces that are horizontal to the direction, or that are horizontal or that are parallel to the direction of motion. I hope you understood this. Let's try to actually explain the inclined plane, because most learners are also getting this incorrect. So I hope that after this lesson you'll be mastering Newton's laws. Okay, they're saying that the surface is rough and we have FA up and incline. Then what you must do, you must just draw this incline, then you put what the dot in the middle of the incline. This is Fn. You can see that Fn is not vertically upward, but it is perpendicular to the surface. Fg, it is vertically pointing downwards. Then we have Fa right here pointing up. The incline, we have rough surface, meaning it's F. Okay, this is FF here. Let me just, okay, FF, yes. So what you must know, whenever FA is pulled, we have components. Even when on an incline, we do have components. So this is what you are required to do. You show that this is FG perpendicular. You do it like this at all times. And you show FG parallel right here. Then these are components. Now you can see that FG and FG parallel and FG perpendicular are components of gravity, or FG, or weight. Therefore FG perpendicular equals mg cos of theta, then FG parallel equal to mg sine theta. Very, very important. Now the motion here is parallel to, the forces here are parallel to the direction of motion, but they are not horizontal. Remember that we said it before. So FA here and FF as well as FG parallel are parallel to the direction of motion. Therefore F net equal to MA. Therefore negative FF, as it is down and incline, even FG parallel, it is down and incline, therefore it will be negative. But FA, it is positive. Why? Because it is pointing up in an incline. So we'll say FA equal to MA, but you can simplify it further, saying minus FF minus MG sine theta, right? MG sine theta plus FA. Therefore the theta that you're going to use or substitute here, so the theta that you're going to substitute here is the theta that you will be given on your inclined plane. Very, very important. So this is how you're doing this. So do not forget to like the video, guys. Please do that. Please do that. It will be unfair for you guys not to like the video or comment. I know you are understanding this. There's something now that you are understanding that you didn't understand before. Let's try to move forward. So make sure, guys, that you understand this video. I don't know how you're going to do that, but make sure that you start the video afresh, then you watch it with understanding. If you understand this, and after understanding it, make sure that you go and attempt past question papers. You'll see how easy Newton's laws is. Okay, what else can we talk about? Oh yeah, I almost forgot. If you see constant speed or constant velocity in your questions, that means that acceleration is 0. Constant speed or constant velocity, it means acceleration is 0. But constant acceleration doesn't mean that f net is 0. Constant speed and velocity, it means f net equals 0. But here you're going to substitute in your formula. Since constant speed means acceleration is 0, where there's acceleration, you substitute 0, therefore f net is 0. Only when it is constant speed, not constant acceleration. Only when it is constant speed or constant velocity. Make sure that you actually mind that. Read your statements. Many learners are not reading the statements. They just want to calculate. Understand the scenario, understand the statement that is written for you to read or to understand before attempting questions. This is very important, guys. But I hope and I know that after this you will be mastering Newton's laws. But don't forget to tell your friend that there's Maths and Science series, okay? For an example, they can actually want you to calculate normal force. You only use this formula only in this scenario or in this case, not on every other scenarios or cases. But if FA is pulled, then they ask you to calculate FN. This is the formula that you use only on this object. It will be FG minus FA sine theta. Remember, you show them the components. You'll be given the value of FA. But whenever you are given an incline, it actually has its formula for calculating Fn. It will be Fg perpendicular, which is mg cos theta. So this is the formula to calculate Fn. You're not using one formula. It depends on the type of scenario that you are given. So this is very important. Very, very, very important. I always tell my learners that you must memorize these formulas because you're not going to be given them on your formula sheet. So make sure that you memorize them and know when to use them, on which scenarios must you use them. That is very, very important. And we do have our classes in Vosloorus. Please do not actually stay at home if you are not having extra classes. Come and join us on weekends and during school holidays. Come and join us. We are offering mathematics, physical sciences, mathematical literacy, life sciences, and accounting. And many other subjects are coming very soon. But please just come. You won't regret, as you can see. So if you understood what I was doing here, please like the video and share it to as many people as you can. Okay, I think I will actually show you the last thing here. For an example, let's say you are given an object, then there's FA here, then there's theta. Okay, this is FA, because there's this question that they normally ask showing a person pushing the lawnmower, the grass cutter machine. So this is FA. I mean, this is FG, not FA. The direction of motion is to the left. Then you do not draw your FA like this. No, this is incorrect because no longer a free body diagram. Remember, a free body diagram, it shows arrows pointing away from the dot, not towards the dot. So you use another notation on how, the notation that's going to show FA on your free body diagram exactly as it is on your scenario there. So this is what you are required to do, or you are going to do. This is very, very important. Make sure that the notation of vectors is not actually disturbed. Okay, so let me just show you how to draw it. This is Fn here, but it is not straight. Let me just try to do it better. It's this pen that I'm using here, it's making me to draw things that are not actually straight. Okay, this is Fn, then you show your FA here, right? This is FA. Then the surface is rough. It means that the direction of motion, it was to the left, meaning FF will go to the right. This is the free body diagram, but let's actually show its component. So you have FAX here and FAY. This is what we are having. So you can use these two horizontal forces to substitute them on the FNet side. Thank you guys. Please do not forget to subscribe. This is the last part of our lesson. Thank you so much.